Okay, now we're going to look at chapter 16, and we're going to start with buffers. This is an application directly dealing with biochemistry and chiropractic, because your blood has a natural buffer in it, and if it gets off balance, it can cause all sorts of sicknesses and stuff. So let's look at how buffers work, and there's a formula for this, and we'll look into all of that. Okay, so practical application. So for example, one of your small dogs or one of your children might eat or drink, I guess, some antifreeze, which is ethylene glycol. Okay, which could cause, blood poisoning and death even. Well, your blood has a natural buffer that helps maintain the proper pH. Okay, what is a buffer? Basically, exactly what it says. It's a chemical in your blood that helps maintain your pH. Okay, so too much ethylene glycol in your body, basically that breaks down that buffer. Okay, it destroys it because there's just too much, because there's a point where the buffer just collapses. Okay, ethylene glycol is acidic, so this causes acidosis. Sorry. Okay, which could eventually cause death if you have too much. Okay, so what's the treatment for this? The treatment is actually ethyl alcohol, or as we know, ethanol. I know that sounds strange, but if you drink ethylene glycol, you should actually drink some ethanol to help. It won't neutralize it. What it does is that your liver prefers ethyl alcohol over ethylene glycol. When ethylene glycol breaks down into the body, it becomes very, very harmful. So the more it breaks down, the more harmful it becomes. So we don't want your liver to break down ethylene glycol. So what do? We give it ethanol, which your body prefers, so the liver gets busy breaking down the ethyl alcohol, okay? And the ethylene glycol passes through the body, so it won't break down into further harmful chemicals, and it won't, mess up the buffer system in our body. Anyway, so let's look a little bit into it, and let's look into buffers. So the buffer in our blood, the chemical in our blood that is a buffer, is carbonic acid. Okay, so if we, what a buffer is, you literally will have a weak acid and a weak base, okay, two different beakers, okay, notice these are two different squares, and what you do is you combine both of these into one beaker, okay, or in the case of our blood, it's in one system, okay, so we have a little bit of weak, or not a little bit, we have a lot of weak acid, a lot of weak base, and usually these are the conjugates of each other that we're looking at, okay, and you add it to one beaker. Now, what happens is this. Okay, let's say, so I have my buffer. Let me draw this. Here's my beaker inside of here. Okay, let's say I have some acid. I'm going to HA for acid. HA. Okay. And let's say over here I add some base in here too. So I'm going to represent that with A minus, A minus, A minus, A minus. So in here I have some acid and some base. So weak acid to weak base. So this is a buffer solution. Okay, and this maintains the pH. So let's think about this. Let me add some strong acid in here. Let me add some hydrochloric acid. So, I'm dripping some HCl in here. What does a buffer do? Okay, well, what neutralizes a strong acid? Base does, right? So what happens is this base right here will neutralize the acid there. Not this acid, okay? It lives in equilibrium with this one, but it'll neutralize this hydrochloric acid, okay? So there is not much of a change, not much change in pH. Because if it's neutral, that means it doesn't affect the pH. It'll affect it just a little bit because we are getting rid of some of the base. Okay, because normally if I put a beaker, okay, and I put some hydrochloric acid in there, that pH will drop dramatically. It will become very acidic. But whenever you have a buffer, it won't change that much. So the same thing. What if I instead added a base in there? So like sodium hydroxide is a strong base. So what if I added some sodium hydroxide in here? So what would neutralize that? That would be the weak acid. So the weak acid will come in here, neutralize this base, okay? And again, it won't change the pH that much, okay? So basically, a buffer has a weak acid and a weak base in there, okay? And what it does, it neutralizes whatever you put in there, or tries to neutralize it, so it won't change the pH that much, okay? So the weak base will always neutralize the acid, and then the base will always neutralize, be neutralized by the acid here. So it's important to realize that you are putting initially some weak acid and some weak base in there. Now we can calculate using the Henderson-Hasselbalch equation, calculate what the pH would be, okay? And in the next, basically, vodcast, we'll go over on the Khan Academy what is this equation here and how to set it up, okay? So the one after that, we'll go over some examples.